Hey guys, I'm going to go over the second review here with all the different types of graphs. All right. All right. So for the first one, we have an exponential. All right. So exponentials, remember, oh, forgot. I figured finally it's only taken me like 2 months of at home teaching to realize that you can change the width of the marker because as you guys have noticed, I've probably been using the same marker width the entire time. All right. So we have a horizontal asymptote and it goes like that. That's a basic for an exponential. Remember, our logs have a vertical asymptote and they go like this. Okay. For these, we use the points 0, 1, and 1, comma, the base. All right. This is the opposite, the inverse of it, 1, 0, and the base, comma, 1. All right, so this is an exponential, so we will be using 0, 1, and we're going to be using 1 comma the base, which in the base in this case is e. All right, so the only thing that is happening, well, two things are happening here. We have this negative in front of the x, which means we have a horizontal flip, all right? A horizontal flip, and we have a number up here in the x, which means it's doing a slide. We have a horizontal slide, so we set that equals 0, and we're going to move it to the right 2. All right, we're going to move it to the right 2. All right, so in a exponential, the horizontal asymptote comes from what's over here of a vertical slide. We don't have any of that, so we have a horizontal asymptote at 0. All right, put a few points in here. Okay. So to do our points, we start off at 0, 1. Horizontal flips, remember, mean that you change. If it's at 0, 1 here, you flip it over the y-axis, which means you're changing the coordinate of the x. Nothing changes there. And then we move to the right 2, so ends up here. All right, so nothing is happening to our y's. All right, so at 1 comma e, which is like right here, horizontal flip makes it negative 1 e. So the right 2 puts me exactly where I started. All right, and it now had just flipped directions, looks like that. Remember, the most important thing is that we label it properly. So it's 2 comma 1, and this one is 1 comma b. All right, so there's my answers for number 1. All right, so for number 2, we have a log graph. So it's going to look like this. So it's going to be 1 comma 0, and the base, which is 2, comma 1. All right, those are going to be the 2 points we're going to start off with. All right, now what kind of transformations we have? The only thing going on is in here. All right, we have an x plus 1 there, which means we set that equal to 0. It's a negative 1, which means we're going to move this 1 to the left. All right, so vertical asymptote is normally at 0, but since it is now moved 1 to the left, all right, we now have a vertical asymptote at x equals negative 1. All right, x equals negative 1. All right, put a few other points on here. Okay, so at 1, 0, all right, 1, 0 is here. All right, and what I'm going to do is just move it 1 to the left to be at 0, 0. I'm normally at 2 comma 1. I move it 1 to the left. I'm at 1, 1. So that's all that happened is we just moved it to just 1 to the left. Everything just got shifted. This whole thing shifted 1 to the left, and that was it. All right, number 3. We have an exponential with a base of 2. All right, so it's going to be 0 comma 1, and it's going to be 1 comma the base. So in this case, it's 1 comma 2. All right, so we have x plus 1 happening there. Set that equal to 0. So that's going to be 1 to the left because it's a negative 1. And then we have a negative 3 here. If that moves it, that's a vertical shift downward of 3. So we're going to be 3 down. So basically what is happening is We're going to subtract 1 from our x's, and we're going to subtract 3 from the y's. That's pretty much all you're doing. All right, exponentials, this number is what affects the asymptote. So we will have a horizontal asymptote at -3, okay? Just trying to, all right. So now, for our actual graph, we go to 0, 1. We're at 0, 1. It's going to move 1 to the left, which means we're at -1, and move down, and we're at -1, -2, right there. And then we have 1, 2, which we're starting here. Move 1 to the left, which means I'm at 0 now. Move down 3, and I'm right there. And I have that as my graph. All right, so make sure you label the points. All right, remember, you don't need all these hashes. You can just put the points. I'm okay with that. All right, so that is 0, -1, and the other point is -1, -2. All right, on to number 4. We have a log graph, all right, that there is no base there, which means it's a base 10. All right, so it's 1, 0, and the base, which is this 10, 1. All right. Now, the only thing, what we have happening here, we have a vertical flip. All right. And we have, that means that's going to change the coordinate of our y's. All right. Because we're going to flip over the x-axis. And then this moves the graph up 2. All right. Now, normally we have a vertical asymptote at 0. And that's what we're going to continue to have right here. Okay. Now, at 1, 0, which should normally be here, a vertical flip changes the y coordinate. Sorry, 1, 0 is right here. All right. Though changes the y coordinate, nothing's going to happen. I'm still at 1, 0, but then I'm going to move up 2. All right. So that is at 1, 2. The reason I didn't write anything here is because this slash marks is because we're going to have to go to 10 here. So we're at 10, 1. All right. And vertical flip it. I become 10, -1. I move up, and guess what? I'm right back where I started. All right. So there is my graph, something like that. All right. So it's at 1, 2, and at 10, 1. All right. There's my answers for number 4. Okay. All right. Now to the next set of 4. All right. Good news. We don't have to do this one because it's identical to number 1. All right. It's the same graph we did in number 1. All right. And I think there's 2 other, like 8 and, oh no, they're not the same. It was changed. Okay. 2 were the same, but then we changed it here. Okay. All right. So we go right to number 6. Okay. We have another log graph, not a base. So it's base 10 again. So it's the same thing we just talked about before. All right. So it is 1, 10, and it is, 1, 0, and 10, 1. All right. So our things that are happening in this graph, this negative right here means we have a horizontal flip, which means we're going to change the signs of the x's. It gets flipped over the y-axis. This whole thing here means we're going to move to the 2 to the, set this equal to 0, 2 to the right. And then this right here, the +3, means we're going to move up 3. All right. Now for logs, we have vertical asymptotes. So anything left or right changes the vertical asymptote. So since we're moving 2 to the right, we are going to have a vertical asymptote going through at x equals 2. All right. Just do a few more in there. Okay. Now, and actually we're going to be on this side of it. I'm an idiot. Okay. So now what we're going to do is, I don't know why I drew all those things because I forgot we're doing a base 10. That's okay. So I'm at 1, 0. All right. If I'm at 1, 0, horizontal flip, and you always do flips first, means I'm going to change the sign of my x's, which means I'm going to go to -1, 0. I'm going to move up 3 and to the right 2, which is going to be right there at 1, 3. All right, so I was at 1, 0. I changed the sign of the x to be at -1. I then moved 2 to the right, which would be back at 1, right where I started, and up 3 at 1, 3. All right, the other point is at 10, 1. All right, 10, 1's over here. Horizontal flip puts me at -10, 1. 2 to the right puts me at -8, 1. Up 3 puts me at -8, 4. Right? And our graph looks like that's an awful arrow. Sorry. So this is at -8, 4. All right. So we change the sign, -10. It moves to the right 2. That's where we got the -8 from. We were at 1. We moved that up 3. So that's where we got the 4 from. All right. 7. We have an exponential. All right. Exponentials have a negative in front. So we have a vertical. Sorry, this has a negative in front. So vertical flip. Our point for this is 0, 1 because it's exponential, and 1, the base, which in this case is 1, 2. And this -3 means we're going to move down 3. All right. We normally have a horizontal asymptote at 0. So we are going to move this down to -3. All right. That tells us our horizontal asymptote. All right. Now, to get the other points, all right, let me start off, put a different color here. All right, at 0, 1, I'm at 0, 1's right here. Vertical flip means I change the y coordinate. So it goes to 0, -1, and then I move down 3, which is right here. All right, a little glitch here. Let's see if we remove, let's see if we get this back without losing everything. And suspense is killing me. I'm going to pause this real quick. All right, sorry about that. Lost connection, whatever happened. I lost all the stuff we had there, but it's already on the video, so you're good. All right, so I tried to write where I thought we were when we left off. All right, so our horizontal asymptote is at -3 because we moved the graph down 3. We have a vertical flip and we have down 3. We're starting at 0, 1. This is exponential. So 0, 1, vertical flip, we change the sign of the y, we flip over the x-axis. I'm now at 0, -1, and I move down 3 and I go to 0, -4. All right, so 1, 2 starts up here. I do a vertical flip. I go to 1, -2. I then go down 3 and I go to 1, -5. And it looks like that. All right, label my points here, 0, -4. And then this is what, 1, -5. All right. All right, 8. Back to a log with base 3. So logs have the 1, 0 is in every log graph, and then it is the base, 1, which in this case is going to be 3, 1. All right. This negative right here means we have a vertical flip, which means we flip over the x-axis, which changes the sign of my y-coordinate. We have a negative here, which is a horizontal flip, which means we change the sign of our x-coordinate, and then which is a flip over the y-axis. So when you have a vertical flip and a horizontal flip, both the x and the y coordinates end up getting changed. And then we have to do one more additional thing, set this equal to 0, and we move 2 to the right. All right, it's 2 to the right for this particular example. Okay, now we have vertical asymptotes when it comes to logs, and that any shift to the right or left affects that. So since we have a shift of 2 to the right, that is my new vertical asymptote. All right. Let's put a few points in here. So we normally start at 1, 0, right? Use a different color. So we start at 1, 0, and which would be right here. I would flip over the y-axis, which changes the sign of my x. Vertical flip does nothing, so I'm at -1. And then I move back to the right 2, and guess what? I finish just where I started, 1, 0. All right. So that point is 1, 0. All right. There we go. All right, 3 comma 1 is right here. A vertical flip puts it at 3, -1. A horizontal flip puts me at -3, -1. And then I move it 2 points to the right, and I'm right here at -1, -1. And there is my graph. All right, so this is at -1, -1. All right. Hopefully you guys are starting to get the hang of this. All right. Same thing over and over again, but we want to give you a lot of practice. So you guys are good to go for the quiz next week. All right. So we have an exponential here. We have an E. All right. And so our point would be with an exponential, 0, 1 is always a point. All right. And we always then have 1 comma your base, which is E. We have a vertical flip going on here. We have a shift of 1 to the left, right? And we go up 2. All right, now this number right here in an exponential affects our asymptote. All right, so we are going to have a horizontal asymptote at 2. All right, at y equals 2. All right. Let's put a few more little points on here so we get a good idea of where we're at. Okay. All right, so 0, 1. So vertical flip means we normally are above here. We're going to end up, our graph should be below. So anytime with an exponential, you have a vertical flip, you should be below the asymptote, okay? So 0, 1 means vertical flip means I change the sign of the y, flip over there. That becomes 0, -1. I then move 1 to the left, which is at -1, -1. Then move up 2, which puts me right about there, which is at -1, 1. All right, 1 comma E, right around here. Vertical flip puts it at 1, -E. Then up 2 puts me right in, and here, and then 1 to the left puts me here. All right, so I was at 1 comma E, which is like 2.718. I then go to 1, like -2.718. Up 2 is like -0.718, and to the left 1 puts me right on the axis. And it looks something like that. All right, so this point here is 0, comma, what did we do the E? We changed the sign, so it was -E, and then I added 2 to it. So 0, comma, -E plus 2. All right. We have a natural log, which means we have a base of E. All right, this has a base of E. This is log base E. That's what it means. All right, so for all log graphs, it's 1 comma 0. All right, and we have our base, comma 1. All right, what's going on in this graph? Well, we have this, which is 2 to the right, and we are going up 1. So we're going to the right and up 1. So this is going to be a slide. There's no flipping whatsoever. All right, we normally have a vertical asymptote. So we are going to do a vertical asymptote at 2. All right, 1, 0. If we move to the right, 2, and up 1 puts us right here at 3 comma 1. Right, 3 comma 1. All right, E comma 1 is roughly right here, starting right next to it. I move over to the right 2, which is E plus 2, and then I go up 1, puts me like right here-ish. And let me draw the curve. All right. And this, what did I do to E? I added 2 to it. And what did I do to the Y? I added 1. 1 plus 1 is 2. So we get E plus 2 comma 2. All right. So we have another exponential. We have the base of 2. So 0, 1, and 1 comma 2. Negative in front. I think you guys are becoming experts at this now, is a vertical flip. All right. This is going to move everything up 3. All right. So vertical flip, and we're moving up 3. All right. So since we're moving up 3, this is going to be our horizontal asymptote. All right. It's going to be our horizontal asymptote. I'll change colors here. So horizontal asymptote is at x equals 3. So 0, 1 is normally here. Vertical flip, right? With my vertical flip, I move to 0, -1. Up 3 moves me here. Probably see we're always like 1 away from this asymptote every single time. All right, 1, 2 is here. I do a vertical flip. It puts it at 1, -2. Up 3 puts it to 1, 1. So I'll draw the graph in there. All right, so our points for this one are at 0, 2, and this one is at 1, 1. I don't like that color. Change this. All right. So we're at a log base 2 for number 12. All right, so we're at 1, 0 is our points to start, 1, 0, and we have the base, 1. Those are our 2 points that we're shifting around for the basic shape. All right, so negative out front, we have a vertical flip. Negative here is a horizontal flip, and we are moving to the left 3 because you set this equal to 0. So for logs, anything that shifts it left or right is what affects the vertical asymptote. All right, so, oh wait, by the way, I'm an idiot. Set this equal to 0. This is to the right 3, not to the left 3. All right, 1, 2, 3. And we put our asymptote, all right, right there. All right, so let's do this color here. All right, so 1, 0. 1, 0 is here. A vertical flip doesn't do anything. It changes the sign of Y, but for 0, it doesn't do anything. But a horizontal flip changes the sign of the X. I flip over the Y-axis, it becomes -1, 0. To the right 3 puts me here, shockingly, 1 away from the asymptote. All right, so that's at 2, 0. 2, 1 is here. Vertical flip puts me at 2, -1. All right, 2, -1. Then I do a horizontal flip, and that puts me at -2, -1. And then to the right 3, oh, it's happening. Oh, it didn't happen. Good. -2, -1. And then I move to the right 3, and that puts me at 1, -1. And there is my graph. All right, so this is at 2, 0, and this is at 1, -1. All right. All right, last 4. All right, last 4. We have E exponential, so 0, 1, 1, E. Negative in front again, vertical flip. No negative in front of the X, so no horizontal flip, but we have a shift of 1 to the left because I set that equal to 0. Since there is no horizontal shift, my asymptote stays at Y equals 0. There is a vertical flip, which means my graph should be down here, right? My graph should be down in that spot somewhere. Okay, so 0, 1, and just to show you, you can do these without making any marks on the graph, all right, if you don't want to. 0, 1 is here, all right? I do a vertical flip that puts me at 0, -1, all right? 1 to the left puts me right around here, which I'm going to label as -1, -1. All right, I flipped the Y coordinate to be -1. I added a 1 to the left, so -1, 1. All right, 1, E, a vertical flip, all right, puts me at 1, E. 1 to the left puts me right around here, which is at 0, E. -E, sorry. All right, so this point is 0, -E. Because it was at 1, E, I do a vertical flip, puts me at 1, E. 1 to the left puts me at 0, -E. So this should say 0, -E. There we go. All right, 14. All right, log base 2 graph. All right, so we have 1, 0, 2, 1. We got a lot going on here. We have a vertical flip. We have a negative X, which means we have a horizontal flip. And we are moving up 1. All right, now nothing left or right, which means our vertical asymptote is still at 0. All right, vertical asymptote is still at 0. Now, 1, 0. All right, if I am at 1, I'm going to put little points here for this one. Okay, different colors here. All right. So 1 comma 0, vertical flip, nothing happens. Horizontal flip, because when you're on the x-axis, you flip over the x-axis, you stay on the x-axis. Horizontal flip, we flip over the y, which changes the x-coordinate. We're at -1, 0. Okay. And then we move up 1, puts me at -1, +1. 2, 1, do a vertical flip, puts me at 2, -1. Then I do a horizontal flip, puts me at -2, -1. Up 1 puts me right there at -2, 0. All right, so that's -1, 1, and this is -2, 0. All right, last two. All right, exponential. All right, exponentials are always 0, 1, 1, the base. All right, those are the points you're starting with. That's the ones you're shifting around. All right, so the only thing, well, two things happening here. We have a horizontal flip, and we're moving 2 to the right because we set this equal to 0. We got a +2. Don't just flip the sign of this and say, oh, it's a -2. So we do a 2 to left. That's not correct. So we're not moving anything up or down. So I still have a horizontal asymptote at 0. All right. Let's actually make this so the pink doesn't. There's our horizontal asymptote. Okay. Points 0, 1. Start here. All right. Horizontal flip. You're flipping over the y-axis. You stay there because you change the sign of the x. You're still there. And I move 2 to the right, and I am at 2, 1. All right. Then for 1, 2, which puts me here, I do a horizontal flip. That puts me at -1, 2. But to the right, 2 puts me right where I started. And your graph looks like that. All right. Make sure you label your points. This is 1, 2. And this one is 2, 1. All right. Last one. We have a natural log, which means it's a log base e. So it's a base e right here. All right. So it's a log graph, means we have vertical asymptotes. The point is always 1, 0. And then whatever your base is, in this case, it is e, 1. All right. Now, what's happening to the actual graph? All right. What is happening to the actual graph? Well, negative out in front, vertical flip, change it. Vertical flip means you flip over the x-axis. We flip over the x-axis, changing the sign of the y. All right. And this -2 means we are moving the graph down 2. All right. Nothing has gotten shifted left or right. So I have a vertical asymptote on the y-axis at x equals 0. All right. Put a few points in here. All right. Just to we start at 1, 0, and E is in there. Okay. Now, for this at 1, 0, it's right here. A vertical flip does not move that at all. The only thing I have to move down is 2. So I'm at 1, -2. 1, -2. E, 1. E is roughly, remember, 2.718, roughly there. Vertical flip puts me at E, -1. 2 to the, then down 2 from there is at E, -3. All right. And the graph then looks something like that. All right. And this point is E, -3, right? Nothing happened to the x. It was just all the y's. You just change the sign of the y, and then you move down 2. So 1, 0, change the sign to 0, nothing happens, move down 2, 1, -2. E, 1, E is going to be the same, but 1, you change it to a negative, so it's -1, change the sign, subtract 2, you get E, -3. Now, the other thing to remember is it's not on here, but domain and range, okay? So for all of these that we've done, the domain of all of our exponentials, all right? So for this one right here, the domain of all exponentials, remember, is -infinity to infinity. The range of all logs is going to be -infinity to infinity. All right. Then the range for exponentials, one of two things. When it's above, it's going to be the lowest point. Y coordinate is the horizontal asymptote. So it's whatever the horizontal asymptote is to infinity, or something like 13, it's -infinity to the horizontal asymptote. So for one like this, it would be 0 to infinity. The range of this one would be negative infinity to 0. The domain for your logs, if it's on the right side like this, is going to be whatever your vertical asymptote is to infinity. So in this case, it's 0 to infinity. Okay. And then if it's on the left side like this one, this domain would be negative infinity to whatever the vertical asymptote is, which is 0. Okay. Also, make sure you know how to do the ones from the first review with trying to figure it right out the function given the graph. All right. I hope you guys have an outstanding weekend. If you guys have any questions, please feel free to reach out. All right. Thanks a lot.